So today the question that I am going to discuss is Leetcode's 101th problem, that is symmetric tree. Okay, so what is the problem statement now? So the problem statement is basically we are given a binary tree. Okay, we are given a binary tree and we have to find out whether the given binary tree is symmetric or not. Okay, so we have to basically return the our value in boolean. Either the tree that we are given will be symmetric, so we will return true, okay, or if the tree that is given is not symmetric, we will return false. Okay, but now what does it mean by being symmetric or not? So if a given tree is symmetric, that means, if I could understand you in a layman language, like let's say this is a given tree that we are given. Okay, now what does it mean by symmetric? So if I like cut this tree from the middle, and if we find out that the left hand side of the root is equals to right hand side of the root in both ways, first structure as well as the value of each nodes in left hand side should be equal to the value in each node in right hand side. Okay, so the structure as well as the value both should be equals to each other, to LHS to RHS. Okay, now here left hand side of the 1 is 2, right hand side of the 1 is 2. Well, both are equal, value is also equal, so it is good by now. Now left hand side of 2 is 3, right hand side of 2 is also 3. Well, this is also a good sign towards being a symmetric tree. Well, now the right hand side of let me first do the work for 3. The left hand side of the 3, we don't have anything, it is null. Okay, also in here the right hand side of 3, the right hand side is, we don't have anything, that is null. The same goes for the now once we check the left hand side, we will go to its right hand side. So right hand side of 3 is also null, and if we check right hand side, we will compare to left hand side of another side. Okay, so right hand side of 3 in here is null, so the left hand side of 3 in here is null. Again we will backtrack. Okay, we will go to 4. Now the right hand side of 2, that is 4, is equals to here's left hand side value, that is also 4. So this tree is a symmetric tree, we can say that. Okay, and also you can just, if you take a view on the tree structure, you can find out whether a tree is symmetric or not. Okay, and after 2 or 3 minutes we will see that what is the algorithm that we can apply in order to check whether a given binary tree is symmetric or not. Okay, so let's move to the another example that is given, that is this tree. Okay, now we have to find out whether this tree is symmetric or not. Okay, so again let's cut it from the middle. Okay, now the left children of 1 is 2 as the right children of 1. So far good. Now the left children of 2, we don't have anything in left hand of the 2, and but in here we have 3 for the right children. So here we have null, but here we have a children. So we can say that this tree is not a symmetric tree. Okay, this is not a symmetric tree because for this node we have null to the left hand side of this node, and for this node we will check it from right now. So in here we have a value that is 3. So this is not a symmetric tree. Okay, binary tree. And also if you just take a look to the structure of the tree, you can just find out whether this tree is symmetric binary tree or not. Okay, now this is what we did by hand. Now what is the appropriate algorithm to solve this problem? Okay, through code. Now what we are going to apply, we will first traverse. Okay, traverse the binary tree. Second thing, in traversing we are using recursion. Okay, we will be using recursion here. Okay, now third, what type of traversing we will do? So we will do a BFS, that is breadth first search. What we call it, this term is taken from mainly graph data structure, but this is same as what we call a pre-order traversal. Okay, now what is pre-order traversal? In pre-order traversal we will first go to root, then left, and after that right. Okay, so first we get the value of root, then left, and after that right. So this is a pre-order traversal that we call a BFS also. Okay, so this is the mainly 3 things that we are going to use, mainly BFS, because BFS includes all these 2 things in it. Okay, now what we'll do, let me point addresses, let me give each node a dummy address. Let's say 1 has stored in 100th address, 2 is here 200, it is 300, 400, 500, 600 and 700. Okay, so we have given each node a dummy address so that we could it will be easy to like traverse. Okay, now as I said, we will do a pre-order traversal. So what we are going to do is we will maintain, well, in question we are given only one pointer, that is this root, that is 100. Okay, now by ourselves what we will do, we will create 2 pointers. Okay, 2 pointers. What will be those 2 pointers? First will be root 1, I'm just taking a name, and second one will be root 2. Okay, now root 1 points at the starting to the left of the root node, root 1, and root 2 will point to the right of the given root node. Okay, so what I'm saying, if I could just write it here, root 1 is equals to root left at the time of initializing, and the root 2 will be root right. Okay, that is at the starting root 1 will be this 200 and root 1 will be this 200 and root 2 this here will be 300 at a starting. Okay, well, we are just derived 2 pointers from a given root node. Okay, what that is root 1 and root 2. One will point to the left of the root node and the another one will point to the right of the root node. Okay, now what we will do, now we have 2 pointers. Okay, we will traverse both the pointers same. Okay, in the same way. What I'm saying here, we will check. Now let me go through the case by case. Okay, now here we have root 1 equals to 200 and root 2 equals to 300. So this is pointing to this node and this node. Okay, now there will be some conditions. First we will check whether root 1 is equals to root 2. We are comparing. Now this will only be true when we will reach at such point where further we don't have anything. Like if we go to left of the root 1 and right of the root 2, we have null. Okay, so only in this condition this will be true. Okay, so now, well, we have null root 1 equals to root 2, so we will simply return true because both are null. And symmetricity, what we call symmetricity, that both the like left hand side and right hand side should be equal in structure as well as in the value. Okay, so we are just fine here if both are null. Okay, now if this root 1 and root 2 is not equal, then what could be the cases? Well, if this is not equal, then there can be one case, that is root 1 of them is null. Okay, root 2 equals to null, one of them might be null. Okay, and if this situation occurs, then we can understand that it is not going to be a symmetric tree. We will return false. Let me show you here as an example that what I'm saying here, root 1, if one of them, root 1 and root 2 is null. Let's say this is root node and this is a right child and we don't have anything in the left child. Okay, and this is 100 and this is 200. Okay, now if we assign root 1 and root 2, so root 1 will be left hand side of 100, that is nothing, it will be null. So root 1 equals to null. I'm just taking an example. Same, root 2 will be right hand side, right children, that is 200. So root 2 will be 200. Okay, now this matches this condition, that is one of them is null. Then we don't have the same structure anymore, so we will just return the false value. Okay, now again what we can have conditions. Let me have another page. Okay, so another condition may be that, well, we don't have root 1 equals to root 2, that is fine, and none of them are null. None of them are null. This means that we have something for root 1, some node for root 1, and also some node for root 2. Now, well, we have a structure. Now, once we have a structure, we will check for the value in the nodes. Let's say we have 3 and 3 for the both of the node. Then it is like good, we can move towards, okay, because it is signing that it is a symmetric till now. Okay, so if this situation occurs that we don't have any one of the node, I mean root equals to null, and also the nodes value are equal, then what we will do, we will recursively call the same function. Let's say this is underscore is symmetric function that we are passing two nodes. What we'll do, we will check, we will call root 1 becomes root 1 left, and root 2 becomes root 2 right, so that further we can traverse the tree and check for the values. Okay, and after that, once if we do traverse like this, once we reach a point where both of them are null, if this is a like symmetric, okay, so then what we'll do, we will change. Then after, what we'll do, we will return root 1 as root 1 right and root 2 as root 2 left. Okay, okay, first this and after that this, so that we check like each and every node properly. Okay, now this was the second last condition, that is we don't have, like we have both the nodes, none of them are null, and the value as well is same. Now the last case that could be is, well, we have both the nodes root 1 and root 2 and none of them are null. Okay, but the value that are inside those nodes is different. Let's say we have here 2 and we have here 3. Okay, then in this condition we will just return false. Okay, only one condition we will recursively call the function, that is when both the nodes, none of them are null and both contains the same value, then we will recursively call the function again. Okay, and now if I could like dry run this code and show you through this like example, that what I'm trying to say, that would be clear. Then let me first draw a tree. Now let's now check whether the tree that I have drawn in here, is it a symmetric or not. Well, by the look we can understand that this is symmetric, but algorithmically let us find that. Okay, let me give those dummy addresses as well. And at the starting we will have root 1 as root, this is root. Okay, so root 1 will be root left, that is 200, root 2 will be roots right, that is 300. Okay, so now we are at this position. Okay, now for each call we are going to check some things. Okay, first we will check whether root 1 first that I show you here na, what root 1, if root 1 equals to root 2, is it true? No, root 1 is 200 and root 2 is 300. It is not true. So then what? That means root 1 is not equals to root 2, and also none of them are null. None of them are null. So none of them are null. Then we will check for the value inside the nodes. Well, we have 2 here also and 2 here also. Good. if this condition matches, that is here, that is here, okay. If this condition matches, then what we'll do, we will recursively call the function. That will be root 1 left, root 1 will become root 1's left, 200's left is 400, and root 2 become root 2's right, that is 300's right is 700, okay. Again we will check for those things. Well, we don't have these two equals, well, good. None of them are null, good. So we again come to this third case, okay, that none of them are equal addresses and we have the same value inside of the each root 1 and root 2. So again we will call the same, root 1 will become root 2, root 1's left, and now we don't have anything in the left, so we will just have root 1 as left null, and root 2 also we don't have anything as null, okay. So now again we will call the function. Now here in this case we are facing, we will counter the first condition, that is root 1 equals to root 2, because null, both are null, and that is the only condition when both of them will be equal, okay. So if this condition matches, we will simply return true. To which we will return? We will return where did we left, here we left, okay. So now we have checked this, now we will check this half part, that is root 1 become root 1's right. So again root 1's right is left null, and root 2 becomes root 2's left, okay, here, so it is also null. Again we will encounter the same here, again we will return true to which he is this node, okay. For this node we have checked the left and here the right, and we are left with this half, so we will check that. That means root 1 will become 500 here, and root 2 will become 600, okay. So this way we can traverse through the tree and return the value if it is a symmetric binary tree or a asymmetric binary tree, okay. If that is a symmetric, we will simply return true, and if it is not, then we will return false, okay, because at the end we are returning false, okay. When the both of them, none of them are null, the root 1 and root 2, but the value that is inside of the both node is not equal to each other, then we are returning false, okay. So that was the pretty much algorithm that we are going to apply in order to solve the question, okay. Now let's go to the computer screen and then try to solve the problem, and let's see how does it go, okay. Well, we are now in our computer screen, and now I'll just code the question and let's discuss. So we are given just a root node. Now before doing anything, let's check for one condition, that if the root is null, the root itself is null, we are just gonna return yes, okay, because that in itself is a symmetric binary tree, okay. Now the main thing comes. So as I said you in the discussion that we will take two pointers, one will be the root left and one second will be the root right. So the structure name is tree node, so here I'll just type tree node, and root 1, that will be root left, and the another root or the pointer mainly that I'm naming root 2 will point to the root right of the root. Well, good till now. Okay, now what we'll do, we will call a function from this main function, because we have to pass both the pointers. Okay, and in main function we are just allowed only one parameter to pass, so that's why we have to call another function that I'm naming as, well, it will return, let me say return, because this function, this main function is symmetric, that is will return a secondary function that I'm naming underscore is symmetric. Okay, and it will take two arguments, first will be root 1 and another one will be root 2. Okay, well, till now it is good. Now below the is symmetric function, create the underscore is symmetric. Okay, that we will take root 1 and root 2 as the arguments. Okay, and those both are of tree node structure type. Okay, so now we are in this underscore is symmetric function that is being called from the main function. Okay, and it is also a bool type. Great. Now first we'll check whether if root 1 is equals to root 2, we are doing just same thing that we discussed earlier. Okay, if that is true, that means both of them are null, we will just return null. Great. Else, now here comes the main part. Okay, if both of them are not equal, then what? Then it could be a condition when root 1 is equals to null or root 2 equals to null. That means one of them is null. It indicates that the structure is not symmetric. Then we'll just return false. Okay, now if this condition is not true, then what? Then we will call else. Okay, now in else, now if we are in here, then we are pretty much sure that both of the root contains some value. Now it's like we will check whether those values are true, values are equal to each other or not. Okay, so we will check for if root 1 val, that is defined here in struct tree node, so that's what I'm writing. If root 1 val is equals to root 2 val, okay, so we will simply return what? We will simply recursively call the underscore is symmetric function. Here first root 1 will be root 1's left and root 2 will be root 2's right. Okay, and after that this will be yeah, we will call again the same function, but this time root 1 will be root 1's right and root 2 will be root 2's left, because we have checked for right now here, so now we will call root 2's left. Great. Now this way we can check for each and every node both of the sides. Okay, now this was the condition for if the values are like equals. Now if the values are not equal, then what? Then do nothing, just return false. Although the structure is same but the values is not equal, then we can't consider the tree as symmetric, so that's why return false. Now we are done with the code. Okay, now let's run this code and see whether it works or not. Well, we got a wrong answer. Why is that? Let me check. Okay, so I don't know why I wrote null here. If both of them are equal, that means the structure is same, so we should return true, na? I don't know why I turned null. That's why the code was not behaving that we expected in the way. Now this is accepted, and also the output is what we expected. Well, good. Now just submit the code and let's see what it happens. Okay, I have actually submitted this code earlier as well when I was doing the question by my own. Now you can see that this runtime is only 4 milliseconds and faster than 91.15% C++ online submission. That's great. And memory use is also less than 62, around 63% C++ solution. That is like huge number, okay, for us. So yes, that was it. We simply solved the question, that is symmetric tree. I hope you would have liked the video, and if you did, don't forget to give it a thumbs up, and also consider subscribing to the channel. That motivates me to make this type of videos on a regular basis. Okay, well, that is it for now. We will catch up again in another video. Till then, bye bye.